Hello, everyone. My name is Rob Higuerita, and I'm a Principal Technical Account Manager here at AWS, and I'm based out of Austin, Texas. Welcome to AWS Supports You, where AWS support experts provide tips to optimize performance in the cloud, lower cost, and provide you with best practices and design considerations. And joining me today, I've got Katya and Luis from AWS joining us. Can you give us a quick introduction, Katya and then Luis?
Sure. Thanks so much, Rob, and happy to be here today. My name is Katja, and I'm a solutions architect based in Munich, Germany. I focus on the topic of sustainability, and I'm part of a company-wide group of different roles that focus on the topic of sustainability. And within my role as solutions architect, I, of course, spend a lot of time on architectural best practices. So how can you optimize workloads for sustainability? And that's what we'll be talking about today. On to you, Louise.
Thanks, Katya. Hi, everybody. My name is Louise, and I'm a technical account manager based in Amsterdam in the Netherlands. And I support customers in the Benelux region on different things, but also on sustainability projects and initiatives. So really happy to be here today and working with Katya and Rob as well.
Great. Thank you both for the introductions and for joining us today. And as Katya was mentioning, Lisa was saying, we're going to be continuing our sustainability discussions this week. And this week, we're going to specifically focus on how you can optimize your AWS architectures for sustainability of AWS services. Before we dive into those details, though, just a quick note to our attendees online, of course, please feel free to use the chat window on the right-hand side of your screen to let us know where you're joining us from today. Also, feel free to share your thoughts, ask questions today throughout the episode to Katya and Luis, who are our experts here on our sustainability efforts. So we'll be providing a link to our survey in the chat as well. So if you'd like to let us know how we did, please click the link and leave your feedback. So Luis, I'm going to turn it over to you to go ahead and get us started with our sustainability discussion today.
Great, thanks, Rob. So as Rob mentioned, we are doing this whole sustainability month this month, which we're really excited about. So last week we gave a talk on making sustainable decisions in the cloud, where we went over the kind of shared responsibility model for sustainability, as well as different kind of best practices, design principles, and metrics that you can use to help make sustainable decisions in the cloud. This week we're going to be talking about optimizing your AWS architectures for sustainability, with a focus mainly on compute, storage, and networking. Next week, we're going to be talking about optimizing artificial intelligence and machine learning workloads for sustainability. And then the last week in June is going to be optimizing your IoT workloads and sustainability through the cloud. So feel free to tune in. It's going to be the same time as this every Monday. But focusing in on what our agenda is for today. So we are going to be first talking about, again, just a quick intro to sustainability that anybody that didn't make last week, then architecting and optimizing for sustainability. So kind of the well-architected pillar, proxy metrics, KPIs, best practices to use as well. And then lastly, applying best practices to compute, storage, and networking. So basically, what we want to do is we want to introduce you to sustainable architecture concepts and metrics for the different compute, storage, and network layers of your AWS architecture. So going on to the next slide. Katya is going to take over and talk about sustainability areas of focus. Katya, over to you.
Thank you so much, Louise. Yeah, so before we dive into the best practices, let's just start with a quick intro to the topic. So what does sustainability actually mean? And here I've brought the definition of the United Nations, and they define sustainability or sustainable development as meeting the needs of the present without compromising the ability of future generations to meet their own needs. So this definition is, of course, quite abstract, but in my opinion, it really grasps the essence of sustainability. Sustainability is a very broad topic. When we talk about it, we talk about, for example, decarbonizing our business operations, water conservation, but also social responsibility and responsible employment or circular economy. And today we'll focus especially on environmental sustainability and initiatives that address decarbonization. And of course, how we as technologists can bring our part to reduce emissions of our IT workloads. And now, just as a quick refresher, if you tuned into last week's episode with Thomas, you may have seen this shared responsibility model already. And if you are already using AWS, this may seem familiar from the shared responsibility for security, but today we'll look at the topic of sustainability. So the shared responsibility model says, in essence, that we as AWS are responsible for the sustainability of the cloud, meaning our global infrastructure, the use of renewable energy, but also reducing water usage or waste management. Also things like partnerships with processor producers to build energy efficient servers, or just investing into energy efficient data centers. On the other hand, you as a customer are responsible for the sustainability in the cloud, meaning your workloads, so designing your applications for sustainability and resource efficiency in terms of, for example, data usage patterns, software design, or which services you're using. And we'll be talking about these best practices today. So Louise, can you tell us a bit more about what it actually means to optimize for sustainability?
Yeah, thanks, Katja. So we're going to move on to optimizing workloads, and basically we as builders or architects, so we have kind of an opportunity or responsibility to optimize these as much as we can. So what does it mean to optimize for sustainability? And we're going to be going through kind of what metrics you can actually use to optimize. What is sustainability in the cloud? Firstly, sustainability in the cloud is a continuous, focused effort on energy reduction and efficiency across all components of a workload, as it says there. So it basically, you've probably been hearing it a lot more recently than ever because it's such a hot topic. But today we're going to be focusing on the environmental aspect of sustainability. So as Katja just showed you, although the cloud is actually more sustainable, by moving to the AWS cloud, your company is already reducing its carbon footprint a lot, but customers still have a responsibility to become more sustainable for your workloads in the cloud. That's what we're going to be kind of focusing on now. So on the next slide then, we're going to be talking about the customer carbon footprint tool. So since March, it's been available to all customers. It's a customer carbon footprint tool, and it basically helps customers to firstly understand the carbon footprint of their workloads running on AWS, but also knowing the carbon emissions associated with their use of the AWS services as well. And this can help customers with their own reporting. It can be very handy for, tracking your progress and analyzing the changes in your emissions over time as well. If you're migrating your workloads to AWS or re-architecting your applications, or if you want to deprecate unused or underutilized resources as well. So we're going to be going through kind of tools we have for this, but this is the tool that will kind of show you these things. It's also really convenient as well for, planning for the future. If you want to forecast your emissions or how your emissions will change across your sustainability journey, this is the tool for that. You can see from the screenshot here, it also shows regions as well. So if your data is in multiple regions, you will see the emissions breakdown by geography, which is kind of cool. And also timing as well. So the emissions are calculated monthly. However, there is a 3-month delay at the moment due to underlying kind of billing cycle of the electrical utilities that supply us with water. So we do have another option as well, other ways to track these metrics and see how your progress is for sustainability, because it is very crucial to define metrics, targets, and KPIs. You need to understand where you are starting from in order to measure your progress and success. So Katja is going to take over here with the proxy metrics.
Thank you, Louise. Yeah, so as Louise mentioned, the customer carbon footprint tool is of course really helpful in order to get these total carbon emissions of what you are doing in the AWS cloud. So it really quantifies the impact here, and that is especially important for reporting, for example. But of course, just having the carbon footprint is not very tangible. We know we want to reduce it, but it doesn't really tell us how we can do that. So I think it's very important to, next to these total carbon emissions, also look at other metrics. And here we can talk about these proxy metrics. proxy metrics are metrics that serve as a fine granular substitute for example, CO2 emissions. And these are now very important if you try to optimize your applications and reduce the emissions. First of all, we can of course look at the resources that we're using in terms of compute, storage, and networking. And we'll also focus on these for today. In general, we want to reduce cost, as in the cloud, we have a pay-per-use model. That means the lower your costs are, the lesser resources you are also using. In order to now put the resource usage in proportion to the work that we do, we should also look at the number of resources we need per unit of work and minimize the unused resources. That could, for example, be how many resources do I need per 100 monthly active users, or how many vCPU hours do I need for 100 completed orders. So essentially just putting this into proportion and being able to compare the KPI to previous month and fluctuating usage. Apart from that, you can also look at increasing the utilization per resource in order to reduce unused capacity. And in terms of networking, we can look at metrics like data size or distance that my data has to travel in order to optimize the overall network utilization. And here it's just important to be aware that, of course, with these proxy metrics, there comes different trade-offs with common requirements such as data retention, response time, or availability. So just be aware of that. For example, if we look at storage, do I need access to all of my data in milliseconds? Or are there any non-critical data that I don't need to store that I don't need to replicate and store in multiple places? All right, so before Louise will dive into some of the best practices, Rob, are there any questions from the audience so far?
Hey, Katya, thanks. Appreciate everything you've been covering so far today. Sorry, a little tongue-tied apparently. Appreciate the concepts and such. I'll let you continue on through here, then we'll probably break again for another question.
Okay, great. Thank you. Then I'll hand over to Louise.
Great, thanks. Okay, so now that we've talked about metrics and the trade-offs there, let's dive into some of the best practices for optimizing for sustainability. So first things first, I have to mention this, the well-architected framework. So this basically helps cloud architects to build secure, kind of high-performing, resilient, and very efficient infrastructure for a variety of applications and workloads. And it does this by basically evaluating architectures and implementing scalable designs. So traditionally, we had 5 pillars in the well-architected framework. As you can see there, operational excellence, security, reliability, performance efficiency, cost optimization. And now, as announced in reInvent back in December 2021, we now also have the 6th pillar, which is the sustainability pillar. So the sustainability pillar enhances the framework to provide a way for you to consistently measure architectures against sustainability best practices, which I'll dive into in a minute, and also identify any areas for improvement as well. So with the focus being on reducing the energy consumption of your AWS workloads. It helps you understand impact and also to get the best utilization for the minimal number of necessary resources, basically, using a series of questions. And basically, it's aimed at helping customers to evaluate the design, the architecture, and the implementation of their workloads to reduce their overall energy consumption and improve on their efficiency. So yeah, it's pretty cool. It's much more than a simple checklist, and it's designed to basically be a tool that customers can use to track their progress towards policies and best practices that support a more sustainable future. So having a well-architected, sustainable workload is a continuous process. So we'll take a look at some of the best practice areas. And first one here is user behavior. So yeah, user behavior patterns can help you identify improvements to meet your sustainability goals. So basically looking at when, where, and how your customers use your workload or their workload. So, and then driving decisions from this on their architecture. And it's not just what they use, but also what they don't use. So anything that they don't use or, is underutilized, they can actually remove those resources. So for example, scaling infrastructure down when it's not needed, positioning resources to limit the network required for users to consume them as well, and removing any unused assets or resources, as I just mentioned. An example of this is if a customer would be running workloads, only on weekdays and not at weekends, then I would recommend for them to consider using spot instances or EC2 instance scheduler, or they can even scale down their infrastructure when it's not needed, and then it will automatically scale up based on the parameters that you set using auto scaling as well. So that's another option there. The next is software and architecture patterns. So implementing software and architecture patterns to help understand the performance of your workloads, and then optimizing the components within your workloads to consume the least resources. So basically working less and storing less and do more work more efficiently. And like I said as well, removing idle resources too. So here you can use sustainable scheduling strategies. I often recommend to my customers to use CloudWatch metrics to assess to monitor your workloads and assess any improvements as well. So CloudWatch provides metrics to identify any underutilized cloud resources, for example. It has specific metrics for storage, compute, and networking, which Katja is going to dive into later on in this presentation. Also using event-driven architectures as well, because they correlate with the level of usage and scale accordingly. And I think that's everything there. Analyzing hardware patterns would be the next one. So minimizing the amount of hardware basically that's needed to provision and deploy. So basically selecting the most efficient hardware for your individual workload. And as a general recommendation, making sure that you also select the right instance type is really important. I often recommend for my customers to use Graviton 2. It's such an efficient processor. I think, it's the most power efficient processor. It has 40% better price performance as well. So it's not just good for performance and sustainability, but also actually great for price. So that's another thing.
There's also, sorry, Louise.
Oh, yeah.
There's also actually the Graviton 3 powered instances that just came out last year at reInvent. They are 60% more energy efficient. So also our most energy efficient processors that you can use. So that's of course a great way to optimize your applications if that fits your workload, of course.
Yes, Graviton 3 sounds a lot better than Graviton 2. So that's the one I should be recommending. Thank you. On to data patterns. So analyzing data patterns to implement data management practices that reduce the provision storage basically required to support your workload. So here you can use lifecycle capabilities to move data to more efficient, less performance storage, if that's what your business requirements are. So colder storage like Glacier, which would be kind of archival storage, or also deleting data that's no longer required. Again, not just from a sustainability perspective, but also for cost. You can also classify data with Amazon Macy and then use the S3 lifecycle policies I just mentioned. And I always recommend to my customers to, gain an understanding about their data, the business requirements around it, classifying it, and then using the right storage technology that suits them the best. When you consider using different storage mechanisms, as Katja mentioned before, just always remember that, you are introducing a trade-off between resource efficiency, access latency, and reliability too. And in your development and deployment process, so looking at your whole software lifecycle to identify improvements for resource efficiency. So that includes, of course, only provisioning test and dev environments when you see it, but also making it safe and easy to introduce and validate improvements in your own software and third-party libraries as well. I often recommend using automation to manage the lifecycle of your development and test environments, and use managed device farms for testing. So yeah, just to give an actual, make it more concrete, I'm going to give an actual example of logging in your application here. So firstly, do less work, store less stuff, sending less information to logs, reducing retention. So, sometimes it's a requirement to log a certain amount of things and send them all to, say, S3 storage. But I often with my customers, I would say, like, do you actually need to store all of these logs, or do you need to store kind of specific logs? Like, can we make this more granular? Then there's less things being recorded and stored, which is great for sustainability as well. So just, reviewing your logs, seeing all the details, deciding exactly what needs to be stored, and then retention, reducing retention. So CloudWatch logs, by the way, just important note, has a retention time. And by default, it's set to indefinite. So you can, to be more sustainable again, you can change this to suit your requirements as well. Next is do work more efficiently. So use better log compression tooling. So using efficient format and compression as well, and then matching the structure and type of logging, matching that to the different data types, basically. And yeah, depending on what you want to do with those logs, there's different compression types for different structures. Driving up utilization, so removing lock contention in logging code. Here you can use asynchronous lock-free logging, so logging does not become the bottleneck, again, making it more sustainable and also improving performance too. Using sustainable scheduling strategies, so you can run batch analytics near midday, not at midnight. Basically, what we're saying here is when you don't care when it needs to be run, distributing your log analytics in time. You can imagine that many customers run their workload at midnight at the full hour. Here you can make use of event bridge rules, cron jobs. If you instead decide to use at a different time rather than the most popular time, which would be midnight, this has less, pressure on the grid. It's more renewable energy in the grid at midday instead of midnight. So here I could recommend as well spot instances that can, run at different times, and then cron jobs too for you to set at different times as well. And then lastly, steer work to more sustainable regions. So storing long-term archives in lower carbon regions. Basically, as different regions have different carbon intensity, you can select regions near Amazon renewable energy projects and regions where the grid has a published carbon intensity as well that is lower than other locations. And this, lets off less emissions and is more sustainable again. So before Kasia describes the best practices for compute storage and networking, any questions from the audience?
Thanks, Luis, and thanks, Katya. Appreciate that. Do have a couple questions that came in from the audience. One from Little Songbird is, how do I make this topic visible for the devs and others in their daily work life? How do we encourage and enable devs to actually improve their applications, like unit tests that are visible through failing pipelines, and if they mess up, on those?
Yeah, that's a really, really good question. I can take that. So I think that really comes back to these proxy metrics that we just talked about a bit earlier, because of course you can't optimize what you can't measure. So if there are no processes in place to actually analyze these different metrics per application team, then you will also not have any idea on how you can optimize these and what impact different best practices and changes have. So here I would always recommend to implement some mechanisms that you can really break down the carbon emissions and these different proxy metrics to an application team. And apart from that, what I often see with my customers is that they just have different goals, so top-down goals on wanting to reduce carbon emissions of the IT infrastructure by X. And then this is, of course, a good goal that you can work on towards, and you can also see how different applications change over time if you assess these metrics. Yeah. Great.
Yeah, no, great points. Thanks, Katya. Appreciate that. And Luis, I have a question for you that came in from Joe Desmond. So this question for Luis, you mentioned choosing the right hardware for your workload or removing underutilized instances. How could you go about doing this?
Yeah, also a great question. So one way to right size your resources would be to use AWS Cost Explorer in the Amazon dashboard. So here you can see, what instance types you're using. And I guess that's probably the best way to do that. Also, you can take a look at, as we mentioned before, Graviton 3 and see if that works for your workloads, as it will be the most powerful processor and therefore, quite sustainable too. As for underutilized resources, so we do have AWS Trusted Advisor, which is our tool it does a lot of things. It gives just good advice, basically. And it has checks for looking at your resources and seeing what's actually underutilized. I think it's under 10%. And then you can actually go and check the resources and then actually see, if they should be removed or if there's a reason why they're underutilized. And yeah, you can talk to, myself as a technical account manager or Katia as a solution architect, and we can kind of help you make the decision as well of maybe you could, scale down your infrastructure rather than delete it if it's being underutilized, and then scale it up when it's needed. There's options like that. Yeah, Katia, if you have anything else to add to work away.
No, that was great.
Yeah, that included a lot of great information, Luis. We'll say also, you mentioned Trusted Advisor, right? But we did also recently integrate Trusted Advisor and Compute Optimizer. So findings and data from Compute Optimizer are joined in there. So that'll help you find those underutilized instances a little easier as well and make those recommendations for you. So you can kind of use those to adjust in the sustainability as well. So a few other questions that came in as well. So thank you everyone for the questions there. We have a question that came in from Cloud Dasher as well. How granular is the customer carbon footprint tool? And can we see how much each EC2 machine family CO2 is under each region? In addition, can we see a breakdown between EC2, CPU, RAM, disk, and IP networking type information?
Mm-hmm. So to make it, first of all, easy, you can currently not see this kind of information. Currently, the customer carbon footprint tool includes a rough emissions breakdown by the services of EC2 and S3, but it's just on the overall EC2 level. So we don't break out what each EC2 family or instance type family, what the emissions are for these. But here, of course, you can look at the different energy efficiencies of, for example, Graviton, because here you will already know that it's more energy efficient than comparable instance types. But from the customer carbon footprint tool, you don't have access to this data. But with regards to the region part, so here you can, for example, look at what or which regions are already powered with 100% renewable energy, or use renewable energy credits in order to offset the non-renewable energy that is being ingested from the local grid. That is, for example, in Europe, Frankfurt or Dublin. So yeah, you can already look at these different types of information, and apart from that, assess these proxy metrics.
Great. No, thanks for that additional information and such. So that kind of goes a little bit into what we had a question that came from 60 Fulcrum about the cost of moving to a low carbon region. Sounds like, kind of gave a little bit of info. Is there anything else you wanted to maybe add about, specifically addressing that?
Yeah. So of course, this is always a trade-off. And it also depends where, for example, your users are located. So, I mean, if we now see that Frankfurt or Dublin are already regions where we have the renewable energy usage or use these renewable energy credits, but your users are maybe located in the US or Asia, then we will have a very large networking cost and large distances. So I think that is, again, a trade-off. And also keep in mind that until 2025, all AWS regions will be powered by 100% renewable energy. So yeah, just think of what does it take to actually now migrate resources or workloads to a different region with that time frame in mind.
Great, yeah, great points there. So appreciate the information. I'll let you continue on through the presentation. I think we're going to get into some applying the best practices on compute storage networks, so I'll let you dive in there.
All right. Great. Then, in order to make it a bit more tangible, let's apply these best practices to the compute, storage, and networking part of your applications. So, compute services, of course, make up the foundation of many of our customers' workloads, which bring a great potential for optimization. And Luis has already touched on some of these different best practices. In general, you can always think of integrating auto-scaling mechanisms in order to automatically scale up and down based on demand or based on time, for example. Because you, of course, may not always know when your users are actually using your applications. And then Luis already just mentioned that how can you actually right-size resources. Here we have different services like Cost Explorer and Compute Optimizer, which give you different recommendations on how you can right-size these resources. Then, as mentioned also before, think about if you can use Graviton-powered instances just because they are more energy efficient by itself, and they also bring in more cost savings as they are more performant. So if this works with your workload, then I think that's a very easy, quick win that you can implement. Then lastly, we also have to consider adopting a serverless and event-driven architecture just in order to maximize overall resource utilization. Here, think of Lambda when we're in this compute layer, because then you, of course, don't need to run and maintain servers anymore, and you also just pay for what you use. And in order to make this even more tangible, colleagues of mine have just written a blog post on how Moya, which is a German mobility and ride-sharing company, optimizes their applications for sustainability. And they also make use of serverless services because, as you can imagine, it's a ride-sharing company. So they have really a lot of users and a lot of vehicles on the road on Friday and Saturday evening. But for the other nights, there are fewer vehicles that are operating. So of course, they also need fewer resources. So they use serverless services in order that the infrastructure can scale automatically depending on what kind of user loads they have. Now, in order to match the supply to demand through methods such as auto-scaling, we can also look at it from the other way. So shaping demand to match the existing supply. And this strategy, of course, makes especially sense for flexible workloads where the exact time to run a certain operation is not relevant. So here we already touched a bit on spot instances, which take advantage of unused EC2 capacity. So essentially you shape your demand to the existing supply of EC2 instance capacity and can improve the overall resource efficiency. Then also think about load spikes in the AWS infrastructure by, for example, applying jitter to scheduled tasks. Think about what Luis mentioned earlier, that a lot of scheduled tasks are run at midnight or at the top of the hour, which of course results in load spikes in the overall AWS infrastructure. So if you don't actually care when a certain operation needs to run, then you can shift this a bit over the hour or apply jitter to these scheduled tasks. And here, if we come back to the example of Moya, some parts of their workload also don't require real-time data. So this data is actually batched and then processed hourly or daily. They also run bigger analytics jobs at night or on the weekends when the energy demand from industry or private consumers is lower. Because here you can also think, or we can, what Luis mentioned earlier, one part think about when is the part of renewable energy very high in the grid, but also when is the initial load on the grid higher or lower. Because of course, at some stages during the night, actually resource usage is low. And Moya's data processing application also uses Spot instances for stateless workloads to increase the overall resource utilization and save cost. All right, then let's move on to the storage layer of your workloads. So here, first of all, we should always analyze data access patterns in order to choose the right storage tier. Because you probably have data that you need to retrieve often, whereas other data you are just archiving. And similarly, there are different storage technologies that fit to these different use cases. So if you have, for example, an archival use case where you need to store slow changing or unchanging data, then you should always think of rather going towards magnetic storage as opposed to solid state memory. And for archiving in particular, think of using S3 Glacier or Amazon EBS Cold HDD volumes. All right, and now we can look at S3 specifically and the different storage tiers that we have depicted here. So if you decide for a different storage service or feature with a relaxed durability, availability, or response time, AWS can in turn use this to make trade-offs and improve resource and energy efficiency. For S3, there's the S3 one-zone infrequent access, which allows AWS to not send all objects over the wire again to another availability zone and just store it in one place. And in the same way, extended retrieval times of Glacier allow trade-offs to use less energy or less infrastructure for operations. So in order to store your data efficiently throughout its lifetime, you can, for example, create an S3 lifecycle configuration that automatically transfers objects to different storage tiers depending on your predefined rules. And now you may also have use cases with unknown or changing data access patterns where you can use S3 intelligent tiering, which monitors the access patterns and then moves objects among these tiers automatically. And here we have just talked about the example of S3, but there are also other services like CloudWatch logs or Elastic File System where you can implement lifecycle rules to tier or purge data according to the business needs. So essentially, no matter which service, look for opportunities to move your data to colder tiers or delete it the less frequently you use it. And of course, be aware of the different trade-offs between resource efficiency, access latency, and reliability. All right, then another interesting topic that Louise already mentioned in the logging example is compression. So here, columnar data formats like Parquet or ORC require less storage capacity compared to row-based formats like CSV or JSON. If we look again at S3, if we store data here in Parquet, it actually consumes up to 6 times less storage in S3. And this is because of different features such as column-wise compression, different encodings, or compression based on data type. And also think about the downstream services that make use of the data that is residing in S3. You may have different analytics services like Athena that take this data from S3 and analyze it. And with Athena specifically, you can improve performance and reduce query costs by 30 to 90% just by compressing, partitioning, and converting your data into a columnar format. And this is essentially because you reduce the amount of data that is scanned. And as a last recommendation here on storage, of course, think of deduplicating data because large data sets often have redundant data. So yeah, just think of deduplicating this. And then lastly, let's look at the area of networking. So here, first of all, think about, can you reduce the amount of network that is traveled per request So essentially optimize the path a packet takes in order to reduce the distance. First of all, in general, think about read local, write global, in order that users can read the data from the source closest to them. So how can we achieve this? Think of choosing a region that is near the majority of your users, because of course, the further your users are away from the region, the further the data needs to travel through the global network. If your users are now spread across different regions, then you can also make use of cross-region replica features of our relational database service or Amazon Aurora to set up multiple copies of your data in each region. Then, of course, you can also make use of a content delivery network like CloudFront, which brings your data closer to the end user and which just caches the content from the original server. And this again shortens the distance that each packet has to travel throughout the network. And lastly, you can also look at edge computing, which brings data storage and computation closer to users. So you can perform data pre-processing or run machine learning algorithms on the edge with CloudFront functions or Lambda at edge. So now this was the first part, so reducing the distance your data has to travel, and then we can also look at reducing the size of the data that you are transmitting. And here we can again talk about compression. So you can, for example, configure CloudFront to automatically compress objects. You can also enhance EC2 network performance by using larger network packets. And this would just enable you to pass more data in a single packet and decrease the processing overhead of sending packages. And then lastly, there are a few techniques to optimize your APIs as well. So if your API payloads are large, you can also think of using compression again, or caching API responses to enhance responsiveness and reduce network traffic. All right, so these were a lot of best practices, and you can also look at the well-architected white paper just in order to read up on these again. But yeah, Rob, are there any questions for now?
Hi, Katya. Thanks. Yeah, that was a lot of great information. Some of the things that we were kind of looking with the audience in the chat, kind of, thinking about all the different concepts there are, and it is a lot, but just looking at some of these, it's quick and easy to see you may be doing some of these things just kind of unknowingly in the way you're storing your data or using those lifecycle policies and things. So really great insights and info. Did have a question that came in from Mike DeMeester. Luis, it's for you. And they mentioned that you had mentioned moving to the cloud reduces carbon footprint. Can you explain a little bit how? You're on mute, Luis.
Thanks. Sorry. Yeah, thanks, Mike. That's a great question. Cloud providers like AWS have a lower carbon footprint because they're just more energy efficient than, I guess, typical on-prem alternatives. They invest in efficient power and cooling technologies. They operate energy efficient servers as well, like the ones we've mentioned. Cloud workloads as well reduce impact by taking advantage of shared resources on the same, let's say, servers or things like that, such as networking, power, cooling, and any physical facilities as well. So you can migrate your cloud workloads as well to more efficient technologies as they become available. So, having the newest type of technology, we're always trying to find ways to optimize the services ourselves. Like as Katya mentioned about the sustainability shared responsibility model, AWS also has responsibility for sustainability too. So we're always trying to enhance our cloud-based services to be as sustainable as possible. And Katya, if you have anything to add, work away.
Maybe just to quantify this a bit more, there was actually also a research study done, or a benchmark of different on-prem data centers, co-locations, and cloud providers, where they essentially just looked at on-prem data centers and got different metrics, like, for example, what is what is the utilization and virtualization rates, what is the power usage effectiveness, so essentially how efficient do you consume power inside a data center, or also metrics like age of servers. And then these metrics were compared to AWS infrastructure. And for Europe, this study, for example, found out that the AWS infrastructure in Europe is 5 times more energy efficient than the average on-prem data center. And this, as Luis mentioned, comes from the higher energy efficiency of our servers, as well as the higher utilization, and also the higher energy efficiency of our data centers itself. And of course, that is an area that we invest a lot in, as we've seen with Graviton and the chip development, for example.
Great, that's great points there. Thank you for the information. I'll let you continue on. Thanks for all the great questions.
Great, thank you. All right, yeah, so I just want to close here with a short summary. So what do we really want you to take away from this session today? First of all, I think the metrics part is so important because, again, you can't optimize what you can't measure. So set sustainability goals and introduce mechanisms to assess these proxy metrics per application. I think that's also really important. Then look through these the set of best practices, look at what can you implement, also see at what is the effort to implement something versus the gain. And then again, look at the proxy metrics to see what was the impact of a certain change. Did that have a good impact, or do I want to roll it back maybe? And yeah, so thanks so much for tuning in today. I just have the slide here again. So if you are interested in the topic, we have 2 more sessions coming up next week, focusing on AI and machine learning workloads, and then the week after on IoT workloads. And yeah, thanks so much for having us, and back to you, Rob.
Great. Thank you both for joining today and giving us such great insights and information. Everyone, today we looked at how you can optimize your workloads for sustainability in AWS. If there are any questions that were not answered today, you can feel free to post your questions on repost.aws, where one of our experts can provide you with an answer to your question. It might even become a topic to one of our shows in the future. So if you have some feedback for us on what you'd like to see on the show, we're going to drop our survey again on the chat box on the right-hand side. And you can also email us feedback at awssupportsyou@amazon.com. We really do want to hear from you and let us know what else you would like to see on the show. And as Katya mentioned, join us next Monday, the 20th at 11 a.m. Pacific time again, where Luis will be back to continue our discussion on sustainability and specifically focusing on optimizing AI/ML for sustainability workloads. So thank you everyone for joining us at AWS Supports You, and happy cloud computing.